Okay. Good evening, class. Just to welcome you to yet another session, Module 10, Network Services. But before we continue on the class, I just want to remind you that it is important that you fill out the attendance form, and then make sure you do your tests, your assessments, chapters 1 to 10. Okay, the chapter tests are grouped into two chapters, so there are just 5 tests you're going to write. Make sure you do them. Latest is Monday. Please do your best to ensure that you do that. Just a minute. Okay. Sorry for that break. As I was saying, we need to ensure that we complete our chapter tests. We have 5 chapter tests you're going to write. Chapters 1 to 10 is going to do two chapters. Okay. Then I also want to let you know that from after today's class, we are not going to have an online class per se. I'll give you free between now and next week. Okay. By next week Monday, so that means we're not meeting Friday. By next week Monday, we should be able to start on our labs. All right, we'll do labs Monday, we'll do labs Friday, Wednesday, we'll do labs Friday. Okay, for that particular week. So these 3 days within the week, that's what we're going to do labs. Then our classes will now resume from chapter 11. Is now going to resume the upper week. So Thomas?
Yes, sir. Good afternoon, sir.
Okay, I can't really hear you. Let me just a second. Okay, yes, Thomas, you were saying something?
Good afternoon, sir. Yes, please.
I can hear you now.
That's the question I asked on WhatsApp. The test.
Yes.
I don't know if you can show us the test on the NetAcad account, because what I'm seeing there is the module exams.
Okay, that's the module exam. That's what I'm talking about. Okay. Sorry. Okay. Yes, the test is the module exam. Okay. Yes, module exam 1 and 2, and then 3 and 4, 5 and 6. Yes, you're very, very right.
Okay.
Yes. So are you okay now?
Yes, that's what I'm asking. Thank you.
All right, thank you very much. Okay, now chapter 10 is talking about network services. Network services. Now, every network has, remember, the aim of a network is to aid communication between 2 or more end devices. Now, there are times when we were talking about the OSI model, and we talked about the different layers. Okay, the different layers: layer 1, physical layer; layer 2, data link; layer 3, network layer; layer 4, transport layer, which we have been discussing. Now, layer 5 is session layer, layer 6 is presentation layer, and layer 7 is action layer. So the network services are usually run within the application layer, within the 5, 6, 7 layers. Okay, on the TCP/IP model, that is called the application layer. So DHCP is the first, stands for Control Protocol. Now, every system that is on your network, for it to function, requires to have an IP address. And we said that an IP address is a 32-bit digit that identifies your system on the network. That's an IP version 4. An IP version 6 is like 128 binary digit that identifies your network on your device on the network. All right. So you cannot have two end devices on the same segment having the same IP address, because they should have different IP address for the identification. Now there are two IP or net. The first way is dynamically, okay, and then the second way is manually or statically. Now, dynamically meaning that you're going to configure a particular service to be able to issue out these IP addresses automatically, all right? And then manually means that you are going to enter the IP address on each of the devices. All right. So usually when you are going to use static is when you are having, let's say, servers on your network, like your local servers, they need to have static, like your routers, okay, like your routers and your servers, all of them, they need to have static IP addresses. Why do we say static IP address? Because you don't expect the IP addresses to change. There are clients that will be communicating with them frequently, and so you need to assign this IP address statically. But when you have systems on your network, and the systems are many, then you need to tell your computer to assign these IP addresses dynamically, right? So as the network and grows, you need a DHCP server or a DHCP server to be able to assign these particular IP addresses. Now, how does this server assign these IP addresses to the client? All right. The first thing is that the client is like a broad, which please hit valley to be able to network. Now, when you have that, it's a DHCP discover, which means that there is a tendency that within that particular network, you can have more than one DHCP server issuing out IP addresses. So important to note is that the client is the first device that will initiate the DHCP discover. Then the closest server that is there will now reply with a DHCP offer, all right? And it offers a lease to the client. We say, okay, I am available. I want to offer you a particular service, the DHCP lease service. Once the client accepts that offer, then the client is now going to send a DHCP request to identify to the server it says the client sends a DHCP request message that identifies the explicit server and lease of the client is accepting. All right, so it sends that to the server. Now, once it sends that to the server will now document that particular request and that particular list to make sure that it does not issue it out to any other client. Then the server will now send a DHCP acknowledge back to the client. All right. So once if the IP version 4 address by the client offered to the server is still available, the server returns the DHCP acknowledge message. If the offer is no longer valid, then the selected server responds with a DHCP NAK non-acknowledged message. All right. that means the message is returned and then the process is beginning all over again. All right, meaning that that IP address is not available. Then the client is now going to now send the discover, then back to offer, then request, then acknowledge. Now that is how that particular messages takes place. So the DHCP message format version 4 message format is used for all DHCP transactions. So the DHCP version 4 messages are encapsulated within the UDP transport protocol. All right, and this is the list that covers the structure of the version 4 messages. All right, so it's going to require the gateway IP address. It's going to get the hardware address, that's the MAC address. It's going to get the server name, all right, and then it's going to get the boot name. All right, just a second, please. Right. So what we are talking about is the DHCP message format. Now we have talked about what the DHCP does. Basically, we said that the DHCP is responsible for assigning IP addresses to end devices. And we said you can do that automatically, or you can do that through static means or manually. And we said the reason where you do it manually is when you want to assign the IP address to maybe servers, to routers, to devices, okay? But when you want to do it dynamically is when you have so many computers on your network. So for you to be able to manage them, you have to assign it dynamically. Now, the next thing that we're looking at is DNS. DNS is domain name service. Now, what is actually DNS? And what is its function? All right, that's what we want to look at now. Now, basically, DNS systems consist of a global hierarchy of distributed servers that contain database of what? Look at this, name to IP address. It contains database of name to what? To IP address mapping. That means it sees a particular name. Can you see this name, for instance, cisco.com? This cisco.com is a name, but it is mapped to an IP address. So the client computer will send the domain cisco.com, but in essence, there is an IP address mapped to it. For instance, now, let me show you this. Let me share my command line. Okay, so for instance, you see, if I do ping cisco.com, right? Look at it. I am getting a reply from what? 72.163.4.185. So how did cisco.com turns out to be this particular IP address? It is because this is the domain name and it is mapped to this particular IP address. So the point we are making here is that the domain name that is mapped to the IP address is managed by what? By DNS. And basically that is its function. Now, DNS have hierarchy. It consists of a hierarchy of genetic top-level domains and numerous country-level domains. I'm sure you know that there is .net, .edu, .com. The frequent one that we know is a .com. .au.co.ng. We have .ng, that is for Nigeria. Okay, we have .mil, that's for military. .this, .that, .that. You see, all these are domains. All right, they are the top level domain. We call them the TLD. All right, these are the TLD, the top level domains. Now we have what we call subdomains, or the second level domains. Subdomains are found at the next level of the hierarchy and represent some divisions of the second level domain. So for instance, you see, if I go ftp.cisco.com, cisco.com, mail.cisco.com, all these, they carry cisco.com. They are under the .com domain. All right. So as many as cisco.com, this is the domain name, the subdomains that are given birth under it can be as many as possible. All right. Then you can have the fourth level domain, and they can represent a host in a subdomain. All right. All right. So the concept of domain names, why is hierarchical, is you can have a, let's say, NBTE, pardon my handwriting, mbte.com. All right. Now, this is maybe your domain name. Now, under this domain name, you can have your classes.mbte.com. You can have ftp.mbte.com. You can have faculties.mbte.com. You can have whatever, as many as possible, but they are under this particular domain name. So how does the DNS lookup process takes place? The lookup process is just the way to resolve this domain name to the IP address. If you type a domain name, how does it resolve it to the IP address, right? If a mapping, excuse me, the resolver will first check its local DNS cache. The local DNS is the DNS of your machine. For instance, this is the PC here. It has its own local DNS cache on this. So it checks for it here, all right? And if the mapping is not found, the query now is forwarded to the DNS resolver, all right? The DNS resolver. If the mapping is not found there, the DNS server will query the higher level of the DNS server. And if the mapping is still not there, then it will now check for the subdomain. All right, it will now check for the subdomain, or it will go for the root, sorry, I say subdomain, the root DNS server. So if the server requires data from a zone, it will request a transfer of that data from an authoritative server for that zone. So the process of transferring this DNS between servers is known as zone transfer. It's known as zone transfer. Now, let's look at the steps that are involved in this lookup. The first step is that the user type the fully qualified domain name. FQDN stands for fully qualified domain name, and that is like putting the whole domain name, cisco.com, for instance. Look at it here. When we have www.cisco.com, that's like the fully qualified. So the user types this domain name on the browser. Once he types this domain name on the browser, step 2, a DNS query is sent to the designated DNS server for the client computer. Now, look at this, for instance. If I come to my Windows and I say ipconfig /all, now you see it's going to look for, this is my DNS server, the DNS server that is querying my listing. Look at it. Where is it, myself? I just lost it now. Look at it here. 192.168.13.1. All right, that is the query that will first of all go. all right, will be sent to the DNS server for the client computer. So the client computer has its DNS server, so it will send that. Then step 3, the DNS server will match the fully qualified domain name with its IP. For instance, here, cisco.com, that is the domain name, and then the address is 198.133.219.85. All right, excuse me. Then the DNS server matches the domain address. All right. Step 4 says the DNS query response is sent back to the client with the IP address of the fully qualified domain name. So once it comes here and say, okay, I type cisco.com and then I got this, and then this is now sent back to the client. This particular IP address is now sent back to the client, because that is the response to the query that the client have done. Now, the DNS server matches the domain with its IP address, which it has done. All right. Once it's sent to the client, this client will now send its message to this particular IP address. Remember the encapsulation process. This is now like the destination IP address. So it will now send its message with this particular, and the message is going to be destined to who? To cisco.com. Remember that this guy wants to browse, all right, but he needs to get to the web browser. So he has cisco.com, but he doesn't know the IP address to cisco.com, how to get to cisco.com. So it's the DNS that will now query and provide it with this particular IP address. Then it will now begin its message. So DNS uses port 53 on UDP for queries and responses. Okay, port 53 for queries and responses. As in, I want to go to cisco.com and then I say, take this IP address for Cisco. If the DNS response exceeds 512 bytes, the DDNS Dynamic Domain Name Service is used. Now, the DNS protocol communications use a single format called a message. All right, that's the format is used. So DNS uses the same message format for all types of client queries and server responses, error messages, and transfer of record information. All right, and so usually it's a question that it asks, like a query. The question for the server, it contains the domain name to be resolved, the class of domain name, and the type and the query type. All right, so the answer usually comes from the server, the DNS server. The DNS resource record or the RR for the query, including the resolved IP address. The resolved IP address is now the one that matches the domain name. All right, then the authority, that is the contains the RR, that's the registrars for the domain authority. All right, then a registrar is where your domains are hosted or registered. Okay, that has who certifies this domain name. When you want to request for a domain name, you register it with a domain registrar. Okay, so additional relevant to query response only consists of RRs that hold additional information that will make query resolution more efficient. Now, dynamic DNS allows a user or organization to register an IP address with a domain name in its DNS. Okay, so the subdomain is mapped to the IP address of the user server or home router connection to the internet. When a change is detected, the DDNS provider is immediately informed of the change, and the mappings between the user's subdomain and the internet IP address is immediately updated. And it's updated so that other clients will not be misguided. Okay, so the DDNS provider service supplies the IP address to the resolver's second level DNS server. All right, this DNS server either at the organization or ISP provides the dynamic DNS IP address to the resolver. Now, this is basically how the dynamic DNS actually functions. All right. So, for instance, I have my user here. All right. I have another user here. Now, look at it. I have a particular hosting server here that manages my DNS. Then I have another hosting server that manages DNS. Now, look at it. This is 113.3. This is 113.11, which means that these two are on the same network. All right. And it's trying to tell us that, you see, when you're having DNS, there's usually a primary DNS and there's usually a secondary DNS. All right. So look at this user here. It says DNS query, DNS reply. This guy sends a query to the internet. All right, and the query is on a domain name, www.cisco.com or www.whatever-it-is.com. He sends a query and he gets the reply. But how does the query goes and replies? This query goes to the internet, but ideally the query goes like this. Yeah? And then this particular guy will now map the information or match the information based on the domain hosting provider, and then gets the authoritative details and then sends the IP address back. So this is how it goes, like this. And then the same thing here, the same thing. Now the point is, if there is a change, how does it happen? It says host informs DDNS provider of changes to IP. If there is a change, all right, then the DDS, this guy immediately sends the changes to this particular server so that users will now take note of the new mapping. This is like the old mapping. This is like the new mapping. All right, so that you don't need to now be going through the wrong route. Now, the WHOIS protocol. WHOIS is a TCP-based protocol that is used to identify the owners of internet domains through the DNS system. The WHOIS, we call it the who and then is. It's like a query. Is that not so? The WHOIS application uses a query in the form of a domain name, fully qualified domain name, for instance, cisco.com. WHOIS is a starting point for identifying potentially dangerous internet locations that may have been reached through the network. Okay, now ICCAN, that is the Internet Control Assigned Network and Numbers Lookup, an internet-based WHOIS2 is used to obtain the registration record of a URL. So I just come to this site and just type a domain name here, cisco.com, and then I say lookup. Once I say lookup, then it gives me the details that I want. So let's check, for instance, I can look up, or we go to WHOIS. Okay, just a second. All right, let me come say is it like this? Look up. All right, using WHOIS. Just forgot. So this is it, for instance. So if I say cisco.com, all right, and then I say lookup. Now let's see what we get. Look at it here. The name is cisco.com. This is the registry ID, all right, that Cisco whatever was registered. Then this is the date it was, okay, client delete prohibited, client transfer prohibited, client update prohibited. Okay, these are like whatever. Then these are their name servers. There are 3 name servers. So when you run a ping, it comes to either of these 3 name servers. And then the registration of cisco.com will expire in 2022. All right, so they are expected to renew it. And okay, these are the details. This is the person that you mail to. This is the phone number. You see, these are just information about who owns that particular email that we are talking about. All right, who owns that particular email that we're, I say email, what do you call it, the domain that we are talking about. Okay, how about NAT? NAT stands for network address translation. All right, now IP addresses, you have private IP addresses, and you have public IP addresses. All right, you have private IP addresses and you have public IP addresses. Now, what is the difference between the two? The difference between the two, number one, is that private IP addresses are not routable over the internet. All right, we're talking about for IP version 4 now. They are not routable, simply means you cannot use them to browse on the internet. Okay, public IP addresses are routable, so you need to do a NAT. For instance, let me show you my IP address, IP config. Okay, just a second. Let me pick my call. Now, this is my IP address for my laptop now. You see 192.168.13.1. All right, 192.168.13.1 is my gateway, then 13.169. Okay, but currently I am not accessing the internet with this IP address. There is a NATing that is taking place. Let me show you. If I come to the internet and I say, let's say google.com for instance, and I say, what's my IP? Just a question. You will see, you see the IP that is showing me is what? 105.112.120. Now, this is the IP of my internet service provider, the IP address that my internet service provider gave me, and this is a public IP address. Why is it that I cannot see this particular IP, the 192.168.13.169? And the reason is because this one here is a public IP address and the other one is not a public IP address. Now, the translation that takes place is managed by NAT, Network Address Translation, and it allows a device with a private IP version 4 address to access resources outside the local network. A private IP address must be translated to a public address. So NAT provides the translation of private IP addresses to public IP address. That's its main function, and is usually at the edge of a router. All right, so one side is local IP address or private, the other side is public IP address. So the configuration takes place here. All right, so a single public IP version 4 address can be shared by thousands of devices, meaning that I can just have one public IP address, like I showed you, the public IP address by my ISP, and even if I have 50 computers within my local area network here, all of them will be having the same IP. If they say what's my IP, they are all going to see the same IP address. All right, now this idea of NAT is because we need to maximize IP version 4. All right, so the solution to the exhaustion of IP version 4 address space is NAT. All right, so NAT is used to conserve public IP version 4 addresses, and is enabled. NAT enabled routers can be configured with one or more valid public IP address known as the NAT pool. So you can have a pool of public IP addresses, So if your systems in your LAN here, they want to go out to the internet, they can pick any of the pools that are here, any of the pools, and then they can go out to the internet. So how does NAT work? It says in this example, PC1 with private IP address 192.168.10.10, as you can see here, wants to communicate with an outside server. This server is on the internet, 209.165. This is a public IP address. So what will happen is that this local IP address will be NATed into, you see here, this is the router here. This is the router here. All right. Now, within the router here, you see this side goes to the public, this side goes to private. So it wants to communicate with an outside server with a public address of this 201. So this is where this guy wants to go to. All right. Because this is where this guy wants to go to. This is where this guy wants to go to. Then you see this particular IP address has, we call it inside local. Then you have the inside global. The inside global. All right, sorry. Then you have the outside local. The outside local is now this guy here. Then you have the outside global. Now, why is it that the outside local and the outside global are the same? But look at it, the inside local and the inside global are not the same. Now, if you look at this, this is an end device, 201.1. It's an end device. This one is a network address, is the family name of this group of network. This is the family name. So this guy is the local IP address of this machine here. All right, so if it's going out, it goes to the family name. The family name is going to now help on how to get to the local address. Now, that's NAT. Then we have what we call the PAT. PAT stands for Port Address Translation. All right, or sometimes we call it NAT overload. And what it does is that it maps multiple private IP address to a single public address. All right. You see, in NAT, like we said, you can have a pool of public IP addresses where you want to translate to. You can have a pool of public. All right. But in this particular case, we are saying that you have just one IP address that is public. All right. So irrespective of the number of hosts that you have in your local network, all of them are going to be having the same public IP address. But this time around, there is a port number attached. So when a device initiates a TCP session, it generates a TCP or UDP source port value, or a specifically assigned query ID for ICMP to uniquely identify the session. So PAT ensures that devices use a different TCP port number for each session with a server on the internet. So PAT adds unique source port number to the outside global IP address. So it means that if this one is going out, you see this port number here. This port number is the source port number that is coming from the PC. All right, this is the source port number. This is the destination. The destination port number is where it is going to. So in the source port number, this is it here. And in the destination port number, this is it. For this guy, the source port number is this guy. The destination port number is this guy. So if you are going to do PAT, the source port number is added at the back of the public IP. The public IP now, all right, is attached at the back of the public IP. All right, so file transfer and sharing. Now, this is another service that that is running on the network. Now, FTP is for file transfer service, and you have maybe a server or a machine somewhere where you dump in a lot of files, and then you have clients that actually want to access this to fetch in information. They want to access it to fetch in information. So an FTP client runs on a computer and is used to push and pull data from the FTP server. All right, just a minute. All right, so FTP sessions between clients and server, we have control connections, and then you have data connection. Now, in control connection, the client opens the first connection to the server for control of traffic. All right, and in the data connection, the client opens the second connection to the server for data traffic. All right, so now how about SMB? SMB is basically for server message block, and basically is used for sharing. Maybe you want to share a printer. All right, you have a printer on the network, you want to share it on a particular machine. All right, you can install a printer on a machine, and then you want to share it with the resources on the network. All right, that is very easy to do. I was thinking I can show you guys that. Anyway, maybe in our practical sessions I'll think of that. So in that case, servers can make their own resources available to clients on the network. So it's kind of very simple. So SMB messages can start, authenticate, and terminate sessions, control file and printer access, and allow an application to send or receive messages to and from another device. Okay, so maybe when you have WinSCP, you have softwares like WinSCP, you have softwares like, how do we call it? FileZilla. You can use them. All right, you have it installed in one computer, you have another one, or sometimes you can share a particular folder on one computer. I can come here, share this particular folder, then I will come in here and then try to access the file and maybe copy it into this particular machine. So sometimes maybe you want to copy music or videos or whatever it is that you want to copy, you want to share amongst yourselves, you can do that effectively. How about email services? Now, emails are basically run by a protocol called SMTP, Simple Mail Transfer Protocol, and also POP, Post Office Protocol, and then also IMAP, we call it IMAP, Internet Messaging Application Protocol. All right. So these protocols help to convey mails from the client to a mail server. For instance, you see, this is the mail server, cisco.com. Okay. Now, this is the address of the mail, recipient at cisco.com. Once it's sent, that cisco.com, remember, it's a domain name that is being registered. So once the mail comes, it comes to the mail server, and then the SMTP, and then it comes back, and then comes to the particular recipient. Now, this recipient is this particular guy here. All right, and it is not this system per se. It is an address on this particular server. This sender has an address in this particular server. So all you are doing is that this sender is accessing this mail server, maybe Gmail, and is sending a mail to maybe a Yahoo Mail server. So from an account in Gmail, it just sends an SMTP mail to an account in Yahoo Mail server. And then the user here now accesses that mail server to download his or her mail. So SMTP message format requires a message header and a message body. So when a client sends an email, the client SMTP process connects with a server SMTP process known in port 25. All right. So when the server receives the message, it either places the message in a local account if the recipient is local, or forwards the message to another mail. Now, when we say local account, is if, for instance, I have a Gmail, my domain is Gmail, and I am sending another mail, my recipient is also a Gmail holder. That means the message is going to be in a local account. That means from the same server, it just moved from one point to the other. All right. But if I'm sending, maybe I'm sending from Gmail to Yahoo, that means I am not using local accounts. All right. So if it is not, if that is the case, it's going to forward the message to another mail server for delivery. All right. So periodically, the servers check the queues for messages and attempts to send them again. If the message is still not delivered after a predetermined expiration time, it is then returned to the sender as unreachable. How about POP? Now, POP is when you want to download these mails to your system. All right. So you are downloading the mail. So it's used by an application to retrieve a mail from a mail server. And that is basically what it does. And it uses port 110, all right, to actually get this particular mail. All right. Then we have IMAP. It's also another protocol described to retrieve message. Now, but the question is, what then is the difference between the IMAP and the POP? You see here, it says when the user connects to IMAP capable server, copies of the message are downloaded. Take note of the word copies. But for the POP, it downloads the entire mail. All right. So it says the original messages are kept on the server until manually deleted. All right. But POP, if you, whatever action you do, it affects also on the server. How about HTTP, Hypertext Transfer Protocol? And that is the protocol that controls our web server. All right. When you want to browse the internet, this is it. That is the protocol. And it says the browser interprets three parts of the URL. All right. The HTTP, all right, the protocol or its scheme. All right. So the index.html, that is the specific file name requested. So if you are browsing, you need to understand that there is a HTML. For instance, if I come here, if I just right click here and I say view page source. Now, or maybe let's just visit, let's say cisco.com, and then let me say view page source. Now, you see, this is like the HTML that we are talking about. This is the interpret. So what we are used to seeing, this is what we are used to seeing. Is that not so? This is what we are used to seeing. But this is the HTML code that is behind. Can you see? This is the HTML code that is actually behind. So the HTML, the HTTP, which is the protocol, what it does is that it helps to read and translate that HTML code. This, in response to the request, the server sends the HTML code for this web page to the browser. So it's the browser that will now interpret it for us. Okay. So HTTP URLs can specify the port. For instance, you can say this, then port 8080. All right. That means you are specifying the port that you want to access. It says query strings are preceded by a question mark. In this particular case, you see it like that. and then a fragment is preceded by an hash, as you can see it here. All right, so that is how they are being interpreted. So HTTP is a request or response protocol that uses TCP. By default is port 80. So when a client sends a request to the web server, it will use one of the 6 methods to get the HTTP, either get or post or put or delete or options or connect. So those are the commands that the commands used to or methods used to by HTTP to get whatever it is that it needs. So we're almost done, so just bear with us. The HTTP status codes are numeric, with the first number in the codes indicating the type of the message. All right, so the first 5 codes indicate groups are 1XX, as you can see here, then 2XS, then 3XS, then 4XS. All right, now the 1XS are basically informational. All right, the common one that we see is 4XS, maybe 403. When you see maybe 403, you know that it's talking about error. All right, client error or something like that. If you see 5 or something, you know that it's talking about server errors that is there. So, but that's just the way it's interpreting it. Look at it, client error. 403 is like forbidden. All right, 404 is like the page is not found. All right, so that's how HTML or HTTP sends you those particular codes. All right, so I think HTTPS is when you want to secure your HTTP. You want to ensure that information that are passing in and out of the in and out of the, how do I put it, the page is secure. And once you have that, then you know that attention and encryption to ensure data as it travels across the clients. Okay, across the client. To be used over. Sorry, my internet is not stable. I'm having